We are going to discuss about Vector and Scalar Resolute. First of all, we will understand what is a vector. So vector is a quantity which has a magnitude and a direction. So suppose this is a u vector. So this will be the magnitude, the length of the line. Also, we can have a vector v, and this is the magnitude of the vector. So these two vectors are parallel to each other. So u vector is parallel with v vector. So in this case, we can write u vector is equal to k times v vector, where k should be greater than 1. Also, we can write v vector is equal to k1 times u vector. So in that case, we can say k1 is less than 1 because it should be a fraction, a decimal number. Now we know what is a vector and what is the magnitude and the direction of the vector. So now let's talk about the unit vector. Unit vector. What is a unit vector? The only difference between the vector and the unit vector is the magnitude of the unit vector. Magnitude of the unit vector is 1, or we call unity, right? So, for example, suppose this is your u vector, and what would be the unit vector of this? So, unit vector can be this. We call it u hat. U hat. Now, the magnitude of u hat vector, magnitude would be 1, and magnitude of u vector is going to be u. So u hat vector, by definition, you can write u hat vector is nothing but u vector divided by the magnitude of u vector. So typically we write u vector divided by u. So this is very important. This is how we define the unit vectors. Now we will extend this idea to xy vectors. Suppose this is x vector, this is y vector in Cartesian. Now we need to find out the unit vector corresponding to x vector. So unit vector corresponding to x vector is x hat, which is written as x vector divided by the magnitude of that. So typically we can write this divided by x. Similarly, y hat is equal to y vector divided by y vector magnitude, and that is y vector divided by y. Now, you might have seen in many books that we define unit vectors as x hat, y hat, or j hat, I hat. So these are the typical notations that we have in books. Now, we will try to think about vector projection. What is vector projection? Suppose we have this u vector, and here we have p vector, right? So what is a vector projection? So we can project this vector u in two ways. One would be we can sort of bend this one towards the p vector, and then this part is the projection in p direction, and this one would be the projection perpendicular to p direction. So now this vector, I would say a o a b. OA vector is the u vector projection towards p vector, and AB vector is the perpendicular projection from P vector. So suppose OA vector and OB vector. So let's say OA vector is A, AB vector is B. So now we are in the process of finding these two vectors. Now, this is how we do this. A vector magnitude, which is the direction of, which is the magnitude of OA vector. OA vector magnitude. Then, how to find that? So we use dot product. We use dot product. Now, we will understand why we use dot product. So what is the essence of dot product? Suppose A dot B. So this would be A vector magnitude, B vector magnitude times cosine theta. So if you look at the right hand side, this is a scalar and this is a vector. B is a vector. So dot product of two vectors gives you a scalar. So that is a um, very important relation. Now we have u vector here and we have p vector over here. Now to find this OA, what we will do, we will find the unit vector in p direction. So unit vector would be p hat divided by, sorry, p vector divided by p hat vector, p hat, the magnitude of the p vector, which is called p hat. So to find OA, what we will do, OA distance, okay, so OA distance, that would be u vector dotted with p hat vector. This will give you OA magnitude. Now, if you want to find out OA vector, that means you have to give a directional sense, right? So this whole thing is a scalar. So if you want to give a directional sense, you have to give the directional sense in the p hat direction. So what you do, you multiply that with p hat direction. That's what you do. So now this is not OA magnitude any more than, so it's going to be OA vector, right? So this OA vector, this one is called the vector resolute. This is called the vector resolute. Vector resolute in p hat direction. So what is a scalar resolute now? Scalar resolute, it's very easy. Scalar resolute would be the magnitude part of the vector resolute, which is u dot p hat. This is called the scalar resolute. This is called the scalar resolute. Now, here in some books, you will see these kind of definitions as well. So now we know p hat is equal to p vector divided by p, right? So using that definition, OA vector can be written as u vector dot p vector divided by p times p vector divided by p again. So I'm just rewriting this. So one can write this one as u vector dot p vector times p vector divided by p squared. Okay, so this is p squared. So what is p squared? It's very important to understand what is p squared. If you know vectors, p square is nothing but p vector dotted with p vector. So and this is called p p square. So also you can write this as p vector divided by p vector dot p vector. So this is your OA. So you can write that in this form, or you can write that in the previous form, what I showed you, u dot p hat times p hat. So the second formula is very easy, and then from the second formula you can derive the um, the one I showed you before. So the previous one over here. So this is OA. Now we will understand how to find the B vector. So this is my P over here, and we found this OA vector, which is A vector, right? So I found it. So what about this B vector? So how to find this B vector? So using the vector addition, we can say that P vector is equal to A vector plus B vector. So if you want to find a B vector now, which is equal to P vector minus A vector. So P vector is already given to you. A vector is nothing but minus P vector dot A vector is my OA vector, right? So we found it before. So this is my OA vector. So um, I would say here, this is going to be uh, this is going to be or here, this is not P here. This is my U vector, right? So and we have to have U here. So U vector. So in our basic definition, yeah, we have the U vector in that direction. So this is the right thing. So and here I have to replace U here. So all good. So U minus, what is my OA vector? OA vector is U dot with P hat times P hat, and that is my B vector. And this is what we need to know. Now, knowing that P vector, P hat is P vector divided by P, so one can write B is equal to U minus U dot P vector times P vector divided by P squared. So I showed you this before as well. So now P squared, we can say U vector dot P vector, outside you have P vector, P squared is nothing but P vector dot P vector. I showed you these things before, and this is P. So you can write that in this way or in the previous way. So in summary, what we have learned, we learned A vector or OA vector, which is our vector resolute in P direction. That would be U dot P hat and P hat. Then B vector, which is AB, we wrote it as U minus U vector dot P hat and P hat. This one, right? So if you want, you can expand it. If you want, you can expand it. Also, both you can expand by using P hat vector is nothing but P vector divided by P. And we know that P dot P is going to be P squared. So if you want P, you can have P dot P squared. So now I hope you can play with these equations, and that's all for today. And if you have any questions, please leave a comment on this. Thank you.